Hello and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 7, Lesson 2 on multiplying polynomials. Before we begin, let me remind you that you can find a worksheet for the lesson and a homework by clicking on the video's description or by visiting our website at www.emathinstruction.com. Also, don't forget about the QR codes at the top of each page. Scan those with your smartphone or a tablet and it'll bring you right to the video associated with the worksheet. All right, let's begin. In the last lesson, we learned about polynomials, which are collections of monomials that behave a lot like the integers, right? They behave a lot like our power of 10 base system. Today, what we're going to see is how we can multiply those polynomials together. Now, we've done this before, a little bit of it, so a lot of today is going to be review. But what we should start with is we should start with monomials. Monomial, or a single term, right, are the simplest of polynomials. When we multiply them together, as we're going to in exercise 1, what we're really going to be using is a lot of the associative the associative property of multiplication. So let's take a look at letter A. Here we've got the monomial 5x cubed times 2x squared. Now, to actually do this multiplication, what we're going to do is use both the commutative and associative property of multiplication to swing it so that that 5 is multiplying the 2, and so that the x cubed is multiplying the x squared, right? Now, of course, 5 times 2 is 10, and we can use that law of exponents that says that we add the two exponents when we multiply two things with the same base. So we get 10 times x to the 5th. Pretty simple. Now, in letter B, what's happening, right? We have actually a simpler scenario. We have negative 3x times negative 8x. Again, what we're going to do is we're going to group the two constants, the negative 3 times the negative 8, and do that multiplication. And also do the x times the x, do that multiplication. Negative 3 times negative 8, obviously a negative times a negative is a positive, and that gives us 24. And x times x gives us x squared. Now, in all likelihood, most students will eventually just look at these problems and say, well, I'm going to multiply the constants together, and then I'm going to multiply the variables together. In letter C, we have the most complicated situation that we're probably going to face, right? We have a monomial here, right? And again, it's a monomial because terms are separated by addition and subtraction, not by multiplication. So 1/2 times x squared times y to the 5th is considered one term, whereas 3/4 times x to the 9th times y to the 1st is considered another term. Again, what we're going to do is group those two constants together, the 1/2 times 3/4. We can also group the x squared times x to the 9th together. And we can group the y to the 5th times y to the 1st together. Remember how we multiply fractions. Multiply the numerators. 3 times 1 is 3. Multiply the denominators. 2 times 4 is 8. Then x squared times x to the 9th. Recall, we add those exponents. And y to the 5th times y to the 1st, again, add those exponents. Don't be fooled by that y to the 1st. Even though the 1st isn't written, we still have to add that power to that one. All right. Multiplying monomials together quickly, effectively, is very, very important because in the next set of problems, we're going to start to multiply more complicated polynomials together. All right? Pause the video now if you need to. Write down anything you have to and make sure you've got this process down. All right. I'm going to clear out the screen and let's continue. All right, in the next set of problems, we're going to start to multiply polynomials by monomials, and sometimes binomials by binomials. In all cases, what we're going to be doing is using the distributive property either once or twice, and we'll see how that plays out. Let's do letter A together, and then see if you can do letters B and C on your own. I know that they probably look more challenging, but I think that you're up to the task. So here, we have this monomial multiplying this binomial. And remember, what the distributive property tells me is that that 2x is going to multiply that 3x, and then that 2x is going to multiply that 1. Okay, 2x times 3x, we can multiply the 2 and the 3 to get 6, X times x will give me x squared. Now this one's easy. 2x times 1 is 2x. Anything times 1 is itself. And there's our final product. All right. What I would like you to do now is pause the video and take probably a few minutes to answer letter B and C. If you have full confidence, you can certainly go on to answer D, E, and F, but I would hold off for just now. Okay, pause the video, please. All right, let's go through B and C. Now again, same idea. We're going to multiply the x squared by 4x squared, and we're going to multiply the x squared by 3. I'm going to keep writing out these products like x squared times 4x squared plus x squared times 3. All right. Again, I'm going to choose to do x squared times x squared and get x to the 4th. And if you want to think about it, I can think about it as 1x squared times 4x squared, so 1 times 4 is just 4. Here, there's truly nothing we can do other than write this as 3 times x squared. It's a little unsatisfying if you think about it. I mean, there's nothing else we can do. We can't add exponents or anything like that. So we get 4x to the 4th plus 3x squared. Now this one looks awfully difficult. But again, just take it a little piece at a time. Okay, we're going to have negative 2x squared y cubed times 2xy. All right. Now, how do we want to deal with this? We've got a negative times a negative, or maybe a negative times a positive that we're then going to subtract. To me, it's easiest to think about it this way. Negative 2xy cubed times negative 5x. Remember, you can always turn a subtraction into the addition of an opposite, right? The addition of an opposite. So let's tackle this first, okay? We're going to do the negative 2 times the positive 2, which is going to give us negative 4. We're going to do x squared times x to the 1st, which will give us x to the 3rd. Y cubed times y to the 1st will give us y to the 4th. Plus, don't forget that, negative 2 times negative 5 is positive 10. X times x is x squared. And then that y cubed, well, that just hangs on. So there's our final answer. Okay, so multiplying polynomials by monomials is certainly something that we've done before. And what comes next we've also done, which is multiplying binomials by binomials. Now there's a lot of different ways to think about multiplying binomials by binomials. All right, all of them though are based on a simple idea. And let's take a look at letter D to make sure that we understand it. The idea is every term in this parentheses must multiply every term in that parentheses. The most, I think, mathematically sound way of doing it is what's known as double distribution, and that's what we've seen before. That's the idea that what we first do is we first distribute this x to the x minus 6, and we distribute a 2 to the x minus 6. We're double distributing. We're distributing both the x and the 2. All right? And then, of course, this becomes 2 of these problems in A, B, and C. So in other words, I do x times x, and I get x squared. And then I do x times negative 6, and I get negative 6x. Then I do 2 times x, and I get positive 2x. And then I get 2 times negative 6, and I get negative 12. Notice that almost inevitably we get two terms here that combine. Negative 6x and positive 2x is negative 4x, and then minus 12. All right, so to me that's the most mathematically sound way of doing it. We're distributing, and then we're distributing again. Okay? Many teachers will use what's known as the FOIL method. All right? And there's nothing wrong with the FOIL method. It's just a mnemonic. FOIL stands for first, outer, inner, and last. Now, what does that actually mean? Well, it means that you first multiply the first two terms. So that'll be 2x times x. Then you multiply the outer terms. That would be these two. And that would be 2x times 3. Then you multiply the inner terms. Those would be these two. That would be 7 times x. And then you multiply the last two terms, which would be 7 times 3. And again, notice the key here is that every term within this parentheses must multiply every term within that parentheses. 2x times 2x is 2x squared. 2x times 3 would be 6x. 7 times x would be 7x. And 7 times 3 would be 21. And notice again that what we have are two terms that combine. 6x plus 7x is 13x. But the 2x squared and the 21 combine with nothing. By the way, have you noticed that when we multiplied that binomial by a binomial, we got a trinomial? When we multiplied this binomial by this binomial, we got a trinomial. Now, I am going to show you one more way to do this type of problem, and I'm sorry about all the different ways. Essentially, though, I'd like to cover many of the different ways that you might see it from a teaching perspective. All right? The last way that people will use, and I like this a lot, is basically setting up a multiplication table or a multiplication box, depending on how you look at it. Putting one of the terms up here, 3x and minus 2, and one down here, 5x and minus 1. And then what happens is we're going to fill these in. 5x times 3x is 15 times x squared. 5x times negative 2 would be negative 10x. 3x times negative 1, which would be negative 3x, and negative 1 times negative 2 is positive 2. Okay? Then what happens is that the like terms always show up right along this diagonal. So we've got that 15x squared, negative 3x and negative 10x is negative 13x, and then we've got the positive 2. So yet again, we've got another trinomial, okay, where two linear terms, two terms that have x to the first, have combined to give us this center term. All of this is quite important as we move forward, all right? So what I may do is mix and match these methods, but ultimately what they all get into is that everything in one parentheses must multiply everything in the other parentheses. All right, so what I'm going to ask you to do now is pause the video. This is a very, very important problem. Pause the video, look at the screen for as long as you need to in order to understand what you have to do to multiply two binomials or a binomial by a monomial. All right, I'm going to clear out the screen. Great. So let's move on to the next problem and continue to get practice on this. Okay, one thing that I don't want you to forget the entire time that you're working on these things is that when you multiply out a couple of polynomials, I don't care if it's a monomial by a binomial or two binomials or eventually even things that are more difficult, what we're always getting is equivalent expressions. And that's important because, again, you might think that multiplying these things out are fundamentally changing them, but they're not. You know, 3 times 5 is the same as 15. Whether it's written as 3 times 5 or 15 is irrelevant. So anyway, exercise number 3 says consider the product of the two binomial polynomials, or just two binomials, x minus 1 times x minus 3. Find this product and express it as a trinomial polynomial written in standard form. That means the terms are descending in power, x squared, x to the first, and then no x is just a constant. Fill in the result in the first row, third column of table B. We'll get there in a second. So here's what I'd like you to do. Write down x minus 1 times x minus 3 and find that product in standard form. Pause the video now and take a couple minutes to do that. All right, let's go through it. So which way should we go? I'm going to go with foiling for right now, all right? And watch how you'll see something that probably many of your teachers do. Here's my first two terms. X times x gives me x squared. Here are my outer terms. Let me label that with a little f for first. Then here are my outer terms. X times negative 3 is negative 3x. That's my outer. Here are my inner two terms. Negative 1 times x is negative x, And here are my last two terms. -1 times -3 is +3. Again, notice how these two terms, those would be the O and the I in FOIL, combine, right? -3x and -x is -4x plus 3. Let me also give you that from the perspective of that box multiplication, right? The box multiplication is just a really nice way of looking at this foiling process. Doesn't really matter which way you do it. In other words, you could have the x minus 3 up here. But it's really great because this x times x, that's that first term. That's my f, right? The x times -1, right? That actually is, well, actually, let me do the x times -3. That's my outer term. X times -1, that's my inner term. And -3 times -1, that's my last term. And again, there are those two terms that we combine to get the -4x. Okay, that's going to be very important because eventually we're going to reverse this process in what's known as factoring. We've talked about that before. But we're going to reverse this process, so you have to be very fluent with it. So what we're going to do now is we're going to put down x squared minus 4x plus 3. And what I'd like to do in letter B is I'd like to really make sure you understand and see with your own two eyes that these two expressions being this one and this one, are equivalent. Now the way we're going to do that is using tables on our graphing calculator. All right, so here comes the magic TI-84 plus. All right, hello TI-84 plus. So what we're going to do with the TI-84 plus is we're just going to examine a table with these two expressions. So what I'd like to do is I'm going to hit y equals on my calculator now. All right, I'm going to clear out any equations that might be in y1 or y2, maybe y3 and y4 if there's anything in there. Probably not, but maybe. All right, so take a moment to clear anything out. All right, and now what I'm going to do is I'm going to put the first equation, or the first expression into y1. In other words, I'm going to put this one in y1, and I'm going to put this one in y2. So in y1, let's put parentheses, x minus 1, make sure that's -1, not -1, x minus 1, parentheses, x minus 3, parentheses. There's no need to put the multiplication sign between them. Your calculator knows you're multiplying with those parentheses. Okay, check to make sure it looks right. No negatives, just subtraction. All right, let's go into y2, and let's put in that second expression. So we're going to put in x squared minus 4x minus 3. Again, watch out, no negatives there, all subtraction. Okay, once you have both of those in, check them over. Did I say minus 3? I don't know. X squared minus 4x plus 3, plus 3. All right, and now what I'd like to do is go into my table setup, because what I'd really like to see is what the values of these expressions are for these 5 inputs. Okay, so let's go into our table setup right up here, and let's make our table start at 0. If your table doesn't already go by ones, that's that little triangle table, meaning your change in the table. Right, we saw that in the slope formula, but make sure that that's equal to 1 if it's not. All right, and now let's go into our table. Remember, we get to that by hitting second graph right up here. So second graph. All right, let's take a look at that table. Now, I think what you can probably vividly tell right away, without even filling in the table, is that both y1 and y2 have exactly the same output values, right? And remember, that's the definition of two expressions that are equivalent. Two expressions are equivalent if, for any value of the input variable, in this case x, they give us exactly the same output. But take a look, I mean, that's exactly the case, right? When x is equal to 0, y1 is equal to 3, y2 is equal to 3. When x is equal to 1, y1 is equal to 0, y2 is equal to 0. When x is equal to 2, y1 is equal to -1, y2 is equal to -1. When x is equal to 3, y1 is equal to 0, y2 is equal to 0. When x is equal to 4, y1 is equal to 3, y2 is equal to 3. So look at those. And I didn't try to game the system or anything. I just picked sort of 5 random x values. You could grab any x value you would want. And what you would find is those two expressions are equal because all we've done is used properties of real numbers, really specifically the distributive property, and then there's a little bit of commutative and associative properties buried in there, but it's mainly the distributive property, to rewrite that product as a completely equivalent trinomial. So never lose sight of that. As we do these algebraic manipulations, we're really just changing the way an algebraic expression looks to serve our purposes. What purposes those are, we'll get to them soon enough, okay? Anyhow, what I'd like you to do is pause the video now, think about this problem, and write down anything you need to. All right, I'm going to clear out the screen. And it's gone. Let's keep moving on. Now, there can be a lot of challenging problems when it comes to multiplying polynomials, but ultimately they're always about everything in one parenthesis multiplying everything in the other parentheses. But what I'd like to make sure is that you've seen some of these more challenging problems. So that's how we're going to spend the rest of the lesson, is on these more challenging products. And let's start off right in letter A. 2x plus 5 quantity squared. A lot of students get this incorrect because what they do is they say, well, I'll just square 2x, which would be 4x squared, and I'll square 5, which will be 25, and that's my answer. But that's not correct. In fact, anytime you see something like this, what I would suggest always doing is immediately writing it as it is, right? 2x plus 5 squared is 2x plus 5 times 2x plus 5. And now I just have to make sure that everything in here multiplies everything in here. So 2x times 2x is going to be 4x to the second. 5 times 2x is going to be 10x. 2x times 5 is going to be another 10x. That's kind of cool. And 5 times 5 is going to be 25. I can now combine these like terms as I so often do. 10x and 10x is 20x, and I get an equivalent trinomial. Now you might say, well, why is that a more challenging product than before? And the answer is, it really isn't. What challenges students is that they make a false assumption that squaring distributes, right? We've heard about the distributive property, and what distributes is multiplication and division. But squaring doesn't distribute. You can't just square the first term, square the last term, add, and move on. That doesn't work. Ooh, let's take a look at another one. X plus 2 times x squared plus 4x plus 3. Here, the method of foiling doesn't really work. Foiling really works when you have a binomial times a binomial. But here we have a binomial times a trinomial. Now, it's not that bad. What we have to make sure of, yet again, is that everything from this parentheses multiplies everything from the other one. So the first thing I'm going to do is multiply everything by x. That's going to give me x times x squared, which would be x cubed. Right? That's that first one. Then x times 4x will be 4x squared. Let me just do a little line here. Then x times 3 will be 3x. And now I've multiplied everything by x. Now what I'm going to do, and let me do it in red just so that we have like a different color. Now I'm going to multiply everything by 2. So we'll have 2x squared. Then 2 times 4x will be 8x. And then 2 times 3 will be positive 6. Now what's interesting about this process is that we've still got like terms, but we have more of them than we do before. There's nothing we can combine with the x cubed. It's the only x cubed that there is. So I'm just going to rewrite that one down. That's kind of like in the last problem, the only thing that we only had one x squared. But the interesting thing here now is that we have two terms that have an x squared in them. We have 4x squared here and 2x squared there. So that will give us 6x squared. Maybe I'll eventually write this all down in the same color. I'm going to go to black now. Look at this. We have a 3x to the first and an 8x to the first. Combine those, and we have an 11x to the first. Now we have absolutely nothing at all, that combines with this 6. All right? So I know that the yellow doesn't show up very well. Oh my goodness, not well at all. But then we just have plus 6. So let me write all of this out in blue so that you can see it. So we have x cubed plus 6x squared plus 11x plus 6. This problem also works particularly well with the box method, but it's just no longer a square. It's a rectangle, and a poorly drawn one at that, right? So in other words, what I could do to multiply this out is I could put a little x plus 2 here, and a little x squared, 4x, and 3 here, and then I could do x times x squared and get x cubed, x times 4x and get 4x squared, x times 3 and get 3x, 2 times x squared and get 2x squared, 2 times 4x and get 8x, 2 times 3 and get 6. Notice again, just like before, the like terms tend to be along the diagonals, right? So we'd have 6x squareds, 11x's, and then that positive 6. All right, so pick your method. It doesn't really matter. Ultimately, you're just doing a lot of distributing such that everything in one parentheses multiplies everything in the other. And by everything, I mean each term. I really should define that a little bit better. We're going to do some more of these, so pause the video now and write down anything you need to. All right, let's move on. More challenging products. All right, more challenging products. Let's take a look at C and D. Oh my goodness, look at C. It's the product of 3 binomials. Oh my goodness. Now, before we even get into the product of 3 binomials, let me just note something. Let's say that we had this problem. Let's say I gave you 3, actually let me write it more the way that it would be if we were back in the day and age where you were doing this. Let's say you had this product, 3 times 2 times 5, right? If you had to do that product, you would multiply 2 of the numbers, get an answer, and then multiply by the third number. And because multiplication is commutative and associative, it wouldn't matter which 2 you did first. So you could do 2 times 5 and get 10, and then multiply by 3 and get 30. Or you could do 3 times 2 and get 6, and then multiply by 5 and get 30. Or, if you were really crazy, you could do 3 times 5 and get 15, and then multiply by 2 and get 30. Right? You could do any of those. So the same thing is true when we multiply polynomials together. We need to multiply 2 together and then multiply by the third. And it's your choice. Your choice. So let's say that we tackle these 2 first, and I'm going to do it by the foiling method. X times x is x squared, that's my first term. X times negative 5 is negative 5x, that's my outer term. 3 times x, that's positive 3x, that's my inner term. And 3 times negative 5 is negative 15. And now I'm going to combine these 2. Always combine like terms when you can. It tends to simplify things, and we get x squared minus 2x minus 15. And now I'm going to multiply by x minus 4. So I'm going to distribute that x times x squared is x cubed. X times negative 2x is negative 2x squared. X times negative 15 is negative 15x. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 2x, watch out, is a positive 8x. And negative 4 times negative 15 is a positive 60. Watch those like terms. Nothing combines with the x cubed, but I have negative 2x squared and negative 4x squared. Remember, we're combining, we're not multiplying. So that'll be negative 6x squared. Negative 15 and positive 8 will give me negative 7x. and nothing combines with the 60. Wow, look at that. That's a tough problem to get through without making any mistakes. Shouldn't be a tough problem to understand as long as you understand the properties of numbers and how to multiply binomials. Speaking of which, take a look at letter D. That's a nice challenge for you. So what I'd like you to do now is I'd like you to pause the video, think about what we did in C, also think about what we did back in letter A, and then try to tackle letter D. I know that's a lot of A, B, C, D stuff going on, but try your best. Pause the video now and maybe even take up to 10 minutes or as long as you really need to do letter D. Okay, pause the video now. Okay, let's go through it. This is a big one. All right, here we go. The first thing that we're going to do is write this as 3x plus 2 times 3x plus 2 times 3x plus 2, because that's what it means to cube something. It means to multiply it by itself 3 times. Now we've really turned it into a problem like letter C, right? These are identical binomials, so it doesn't really matter, but I'm going to start by multiplying these two together. 3x times 3x will be 9x squared. 2 times 3x will be a positive 6x. 2 times 3x will be another positive 6x. And 2 times 2 is a positive 4. So we're going to get 9x squared plus 12x plus 4. And we still need to multiply that by 3x plus 2. So now I'm going to distribute this. 3 times 9 is 27, and x times x squared is x cubed. 3 times 12x, well, 3 times 12 is 36, and x times x is x squared. And then 3 times 4 is 12, and as I like to think about it, the x comes along for the ride. Then we'll do 2 times 9x squared, and let me just show you something that's kind of cool. Watch this. I know it's going to be an x squared. So I'm going to actually put it right underneath here. That's going to be 18x squared, and then I'll do 2 times 12x, which will be, whoops, I made a mistake here. I'm sorry. That's not a 12x squared. That's just a 12x. 2 times 12x is 24x, and then 2 times 4 is positive 8. And now it's more like adding two numbers, right? In that classic elementary way. Nothing's adding the 27x cubed, right? That's similar to having like a thousands digit. Then 36 plus 18 is 54. X squared, watch out, don't do anything weird like tell me that that's x to the 4th. That only happens when we multiply, not when we add. And then I've got 12x and 24x. That's going to be 36x. And then nothing adds to the 8. Ooh, look at that. 27x cubed plus 54x squared plus 36x plus 8. I wanted to look down at my cheat sheet just to make sure that I did it right, you know, because you can go through a problem like that and you can always make mistakes. One good way to check to see if it's right or not, right, is to actually do what we did back in problem number 2. Actually put this into y1, the original, put this into y2, generate a table, and see if they give you the same values for the same x's. If they don't give you the same values, then you've likely made a mistake. Then you've definitely made a mistake. All right? And if they give you the same outputs for the same inputs, then they're equivalent. All right? So pause the video now, really think about what I did on this page, and then we'll move on to the last couple problems. All right, I'm clearing out the text. Or I'm trying to clear out the text. There it is. Okay, let's look at one last one. Okay, we're back to the easier multiplication. Exercise 5 says, consider the product 3x plus 2 times 2x plus 1. Letter A just says write this product as an equivalent trinomial. Expression in standard form. So I'd like you to do that, please. Pause the video and take a couple minutes to multiply those out and express it as a trinomial in standard form. We'll talk about that maybe a little bit more once you're done with letter A. Pause the video now. Okay, let's go through it. I'm going to rewrite the problem here just so that we have it. 3x plus 2 times 2x plus 1, right? So 3x times 2x is 3 times 2, which is 6. X times x squared, so that's my first. 3x times 1, well, anything times 1 is itself, so that's 3x. Then 2 times 2x, well, 2 times 2 is 4. The x comes along for the ride. And 2 times 1 is 2. Here we're going to add, and we're going to get 6x squared plus 7x plus 2. Now just a comment, because I should have mentioned this earlier. Standard form. That's a piece of terminology you're expected to know. So standard form, which we've talked about before, is always having these powers descend. Notice we have an x to the second, an x to the first, and in a certain sense, we have an x to the 0 on that last term. Remember, anything to the 0 is 1. I don't mean to make that too confusing. My point is that if they had said write this out as a trinomial, but they hadn't said write it in standard form, you could have easily written the final answer like this. Right? That's equivalent to this, but it's not written in standard form. All right. And now let's take a look at letter B. I like this problem. How can you use your answer from A to evaluate the product 32 times 21? All right. Find the product and then check using your calculator. So in other words, find the product using something that we had from letter A and then check using your calculator. All right, pause the video now and think about this, especially in light of what we did in the last lesson. Think hard about what we did in the last lesson, Introduction to Polynomials, and then think about how you can use that to answer letter B. Pause the video now and take a few minutes to think about this. All right, let's go through it. So really, what is 32? 32 is 30 plus 2. 21 is 20 plus 1, right? I'm going to take this a little bit farther. 32 is really 3 times 10 plus 2, and 21 is 2 times 10 plus 1. That looks awfully similar to 3 times x plus 2 and 2 times x plus 1, right? I mean, look at this compared to this. The only difference is here, there's a 10, and here, there's an x. Now, we know that this is all equal to 6x squared plus 7x plus 1. So if x is 10, then this is 600, this is 70, and this is 1. And so the product would be 671. All right? And you can easily check that on your calculator. If you take your calculator out now and you type in 32 times 21, whoops, man, what happened here? That's not 6x squared plus 7x plus 1, it's 6x squared plus 7x plus 2. I am just a mistake machine today. I'm like, that's not what we would get. And I'll make this into a 2 and it'll just be a messy 2. 672. Oh my goodness. It's good to make mistakes. Math is all about making mistakes and learning from them. All right, making these videos, that's all about me getting confused apparently. Anyhow, the point in this problem is to again draw the parallels between what we're doing with polynomials and what can be done with integers. Because polynomials are really integers that have just been generalized, right? With the x taking the place of 10, and the x squared taking place of 100, and x cubed taking the place of 1,000, etc. All right, well, please excuse my mistake on that. Pause the video now and write down anything you need to, and then we're going to finish up the lesson, okay? All right, I'm clearing out the screen. All right, let's finish up. So today, honestly, was mostly review. You had already seen how to multiply monomials and even multiply out binomials. Maybe some of those more challenging polynomial multiplication problems were new, but ultimately speaking, it's a lot of the distributive property, right? And a lot of exponent rules as well, especially adding those exponents together and combining like terms. You'll get a lot of practice on this in future lessons, especially as we try to reverse the process in what's known as factoring. So make sure to really take your homework seriously, right? Really try to get some fluency with these processes, okay? For now, I'd like to thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. But yeah, until next time, I'm Kirk Weiler. Keep thinking and keep solving problems.